Now we'll try the second problem. This is a present value problem, so we want to make sure we have the future value problem that we just worked and now a present value problem. You can tell a present value problem because it usually has to do with someone borrowing money. So they're buying something today, so you have a present value, that's the cost of it, and you want to pay that off with payments into the future. And so we're going to be using this formula here. The present value equals a payment times a present value interest factor annuity all rolled over. We're usually trying to figure out how much the payment is going to be. So this is a great thing to set up if you're ever going to a credit union or a bank and you're trying to decide. Sometimes you go to the dealership, and you'll see this in one of the problems. You'll have to work it out. I'll give you some hints in this video on how to work that out. But the credit union might give you a better rate, but the car dealership might give you a rebate. So do you pay 6% at the credit union, or do you pay 6.5% at the auto dealership but get a $2,000 rebate, or whatever the numbers are? So I'll hint at what you can do to answer that part of the financial application. But here we have the same thing we had before. We need to put the rate in. We need to have time. We need a target of what are we borrowing money for. And then we're going to put both the present value interest factor of an annuity and the future value interest factor annuity. We'll put them both in there. Once you set up the first one, I could have just taken this first problem set and copied the whole thing over, and all of that would have been set up, but I'm building it from scratch. So when you do problem 3, you can just take problem 1 or problem 2, click here, and right click and copy and move it to a new sheet, and then just hit enter, and you can do the problem there. So you don't have to recreate all of this from scratch each time. So let's look at this one. Jumbo Wallet wants to buy a car. He will pay back the auto loan over 5 years. All right, so 5 years, bi-weekly. Now, does bi-weekly mean twice a week, or every 2 weeks? Here I mean every 2 weeks, or there's 26 weeks, bi-weeks, 26 bi-weeks in a year. The car is $78,000. There's the target, and the bank is going to charge him $572. So remember, on the rate you put 5.72%, but he's paying bi-weekly. So however many periods there are a year, 26, you'll divide by that. Remember, on the rate, you divide by the number of payments in a year. Here again, I'm going to click on the percent and give it 2 decimal places. On time, you take the number of years, 5 years, times the number of payments. So what you multiply on the rate, what you multiply on the time, you want to make sure that's what you're dividing by on the rate. They should always be the same number. So what is our target portfolio? Well, he's going to buy a $78,000 car, which to me would be a luxury car. Some of y'all, that might not be all that luxury, but for me, that's a luxury car. So $78,000. And then again, we'll do this formula. It's good practice. You do it exactly like it's in the formula over here on number 5. So 1 minus 1 divided by 2 parentheses. 1 plus, make sure you click on the rate. Don't type it in. Close parentheses, shift 6, which gives you the caret. And you want to raise it to 130 bi-weeks. Close parentheses, divided by 0.22. Remember, it should be less than 130, but not radically so. It shouldn't be like 7 or 8. It could be 110 or something like that, but it won't be radically off. And again, we want to go out 4 decimal places. Same thing with the future value. So we did this before, so it's good practice. Open parentheses, 1 plus the rate. Close parentheses, raised to the time, minus 1, close parentheses, divided by the rate. Here we should get something greater than 130. It shouldn't be like 17,000, but it could be like 150 or something along those lines. And so give it 4 decimal places. So now we have everything we need. Now remember, on problem set 1, we had time, beginning value, investment, interest earned, ending value. We're going to use essentially the same titles almost. It'll be slightly different. The first column is the same. The second column is the same. The third column, instead of, keeping the same order, you can switch these 2 columns. So third column is not your investment, it's your payment. The fourth column is interest, not interest earned, but interest expense. So on a loan, you make a payment and you have interest expense. On a future value problem, you have an investment, you have interest earned. And then the last column is the same, ending value. Oops. So again, fancy it up, whatever kind of background you want to have. I'll go wild this time. So just something, give it your own unique signature. Since this is dead, I'll use red, make it look horrifying maybe. And we start with time at time 1. Our beginning balance, to remember when we're doing a future value problem, our beginning balance is 0. Here we're doing a present value problem, so our beginning balance is we'll actually do equal and go up and find that target. How much are we borrowing? Here we're going to borrow $78,000. I'm going to give it 2 decimal places. And we're going to try to get that balance down to 0. What's our payment going to be? So here, remember the payment equals the present value, the $78,000 divided by the factor. So this formula over here to the right. So we're going to do equal the target amount divided by the present value interest factor. We'll put that in there. We'll put it as dollars and cents. Our interest expense is exactly what we did before. Remember on the future value problem, we took the beginning balance and multiplied by the rate. We got 0 because our beginning balance was 0, but here we will not get 0. So we do equal our beginning balance times, and you go up to the rate, and you want to lock that in. Now, if you have a Microsoft Windows product, you can hit your function 4 key, and that will lock it in. If you don't, if you have an Apple, I think it's command function 4. I'm not exactly sure. But if you can't figure it out, you can just go in, just click on the formula and you can go in. So you click on the formula, you can go over and actually put the dollar signs in the formula. We need the dollar signs because as we copy this down, we always want to refer to the beginning balance for that period, but we always want to multiply it by 0.22. Then our ending balance, remember on the future value, we added the 3 across. We don't do that here. So watch what we see if this makes sense. We're going to take our beginning balance, subtract our payment, but add the interest. So our payment will reduce how much we owe the bank, but we add back to that the interest the bank gets there. So let me put these formulas over to the side. So the payment formula, and I'll shrink in this column so we can see a little bit better. So that's column C, the interest expense. Again, you don't need to do the stuff over here on the side. All of this is just to help you get through the video, so you can leave all that out in your answer. Column D is just that beginning balance times the rate locked in, and then the ending balance is you add the beginning balance minus the payment plus the interest. All right, and then over here we'll just do equal A11 plus 1, just like we did on the previous one. You want to now bring this down for 130 rows. So if row 11 is row 1, we probably need to go down to row 140. So let's go down to row, oops, one or too far. I usually don't do it like this, but it's fine. We can do it like that. So that gives us 130. So that worked. Remember, you can do control and the up arrow to get back up to the top. Remember, control down, control up gets you around the spreadsheet. What is our beginning balance? Our beginning balance is the previous ending balance. Our payment, we just reference that payment. You just do equal C11. Interest expense, you can actually drag that down. There's no reason to change that. Ending value, you just drag that down. And then if you highlight these, don't highlight column A, but if you highlight B, C, D, and E, you see that little green square in the corner. You just double click on that. What Microsoft will do is will copy it down as long as there's something in column A. Once there's nothing in column A, it will stop. So if you come over to E, hit your control button and leave it down and hit your down arrow, you'll notice that the ending balance is 0. You notice it has parentheses there. It doesn't go exactly to 0. There's a little bit of a rounding problem, but it gets pretty close. So at the very, very end, we have no amount left. All right, so that's the answer to this one. If you got all that to work, you got the answer. Now you have another problem which is going to ask, what if the dealership gives you $1,000 benefits? Or maybe you set this up for the credit union, and the credit union charges $572, but maybe the dealership charges $640, but they're going to take $2,000 off. So how would you calculate that? Well, the key is the payment. The payment is what you pay. So if you just do the sum, you do equals sum, S-U-M, open parentheses, and go down here, and I'm going to show you a little trick here. We want to add up everything in this column, but we don't want to have to do the mouse all the way down. That's too much. If you go down there and then do Control and Shift, hold the Control and Shift buttons down together, and then your down arrow, you will highlight that entire thing, let up on the Control and Shift, then hit the Shift button and close the parentheses, and that will give you the total. So your total payments here will be $89,770.14, or obviously it's just the $690.54 times 130 payments. Oops. So all you have to do is say, okay, well, if that's what we have with the credit unions, so $89,770.14, what if the dealership charges 6.4%, but they take $2,000 off of this? You can see with them, your total payments is only $88,900. So you'd be better off with the dealership, even though their interest rate is higher, because some of their payments is $88,900. With the credit union, I just typed that number in, you'd be paying $89,770. So when you get to that problem, that's all you do. Some students say, well, we just add up all the interest payments, but that's not it. The interest payments don't capture it because your interest payments doesn't include the fact that you're paying $6,000 less in principal. So you need to include both the principal and the interest, and that's what the payments do. The payments are actually covering both principal and interest. So when you get to that problem, that's the approach to do it. So you now have 2 problems done. If you look at the finance applications, you'll see there's a few other problems. And they ask you a few tricky questions, but if the critical thinking's there, you're understanding what we're doing here, you should be able to logic through those. You have to do your own work. However, I don't mind you asking a peer how they handle the problem as long as you do your own work. And again, give me some unique coloration and style and something so you have your own styles. So I know you did your own work. So that's it for that example. Hopefully these get easier and easier each one you do. And I think you can see from a personal standpoint, this is really powerful stuff.